All right, so I'm not sure if you noticed or not, but all of those shapes and all of those molecules had no lone pairs. So if we're talking about molecule shapes with lone pairs, it does look a little bit different. Those lone pairs do have a different effect than two bonded electrons. Um, so when that central atom in a molecule has one or more lone pairs, the lone pairs require more room. They need more space than the bonding pairs because they are hanging solely around that central atom and not spread between the two. So they require more room around that central atom. Um, and what those lone pairs tend to do is they will compress the bonding angles or the angles of the bonding pairs. So lone pairs tend to compress the angles of the bonding pairs because they need more room. So they squish everybody else together so they can have that more room to spread out. Um, so, like in this example, in a tetrahedron shaped molecule with four bonds, the angle was 109 degrees. Right? Remember that from the last one? In a bent molecule, the angle is less than 109 degrees. So when we have those lone pairs, they squish the angle for the bonded pairs, which you'll see better here in these examples. Um, so the first shape we have is called bent. Um, Basically, here we have two bonded pairs and two lone pairs. So we get that bent structure. Water is the biggest example of this, right? These two lone pairs around the oxygen, remember we got to have 8 electrons around oxygen, 2, 4, 6, 8. So there are those two lone pairs. They need more space. So they squish what would have been and what was in the last section with no lone pairs a straight line. These lone pairs squish the two bond angles together. So before they were 180, now they're less than 109. The lone pairs squish them together to get this bent shape as opposed to linear. The next shape we have is the trigonal pyramidal, which is named the same as the last one, right? This time we have 3 bonded pairs and 1 lone pair around that central atom. We get that trigonal, it's like a triangle pyramid, a triangle based pyramid with the lone pair going that direction. The next shape, called a T shape, which you can see better in this example, because of the lone pairs and one of the atoms are on this one plane, and then you have an atom going up and an atom coming down. So this time we have 3 bonded pairs and 2 or 3 lone pairs around the central atom. We get this T shape. All right. The next shape we want to talk about is called a seesaw. And actually, it looks more like a seesaw if you put it this way. With these two being the legs, and then this being, like the teeter-totter, the part where you would sit on. Um, anyway, it looks more like a seesaw from that direction. But the seesaw is when you have 4 bonded pairs and 1 lone pair around that central atom. You get that kind of a seesaw structure. The next is a square pyramid. So you have the 4 base pyramid with the apex going up like that. Right, square pyramid. So this time we have 5 bonded pairs and 1 lone pair. Makes that square pyramid. If there are 4 bonded pairs and 2 lone pairs, we get the square planar. It's all in one plane, remember, just flat like a piece of paper. And it makes a square because there's 4 of them. Now, the last shape is called linear. This time we have 2 bonded pairs and 3 or 4 lone pairs. So you can see it's a straight line of the atoms, and then here are the 3 or 4 lone pairs in a different plane. But the atoms actually make a straight line. All right, so let's kind of fill in these notes here. So as the number of bonds and lone pairs increase, the structures obviously become more complex, but same general principles. We're trying to keep everything as far away as possible and still have it be connected, and the lone pairs take up more space. Right? So like we said have been saying, lone pairs repel bonds more than bonds repel bonds. And if there are 6 total electron pairs, whether they're bonded or lone pairs, the structure has a modified octahedral shape. Okay. The number of lone pairs makes a difference. Easier this if it has 1 lone pair, this if it has 2 lone pairs, this if it has 3 lone pairs, right? 1, 2, 3. They all have that same sort of octahedral shape. 1, 2, 3 lone pairs make them have a different name. So those are the shapes if you have lone pairs. Like I had said earlier, I will get you a cheat sheet that has all this information on it. That's really helpful in tests and things of that nature. And for your assignment that you have to do with these shapes. That cheat sheet will be important. I'm going to post it in Canvas here in a couple minutes.